Okay, good afternoon. Let us start. Is the screen is visible? Okay, thank you. So we are discussing about MOEA techniques, multi-objective evolutionary algorithms. That is, these are the techniques which are used to solve multi-objective problem by using genetic algorithm. The genetic algorithm techniques which are used to solve most problems are called as MOEA algorithms. Okay. Whereas the genetic algorithm techniques which are used to solve single objective problem are just called as GAs, genetic algorithms. So, so we have discussed like different ways of categorizing these algorithms in the last class. So, so one of the another way of so there are basically two ways of classification, right? One is a priori approach, posteriori approach. Otherwise, these algorithms can also be classified as Pareto based approach and non-Pareto based approach. So some of the so we are not discussing all the algorithms. We are discussing few algorithms. So we have discussed this lexicographic or it's asking admit. I don't understand. So we have discussed lexicographic ordering, and we have discussed SOEA, lossless, and also we have discussed Vega. Okay. All these three things are actually non-Pareto based approach. They are not Pareto based algorithms. So in today's class, we'll be moving on to Pareto based algorithms. Okay. So first we'll start with an algorithm called MOGA. So this is also an MOEA technique, that is multi-objective evolutionary algorithm, but it is based on Pareto based technique. That is, it will give an Pareto optimal solution. Pareto optimal solutions are non-dominating solutions. This is what we are going to discuss, MOGA, which stands for multi-objective genetic algorithm. So this algorithm is a Pareto based approach. This was proposed in the year 1993 by these two persons, Carlos M. Fonseca and Peter J. Fleming. So basically, it is this algorithm is proposed through this paper. So this is a research article. It is published in this particular conference, Fifth International Conference of Genetic Algorithm. So you can search it in Google and you can go through this paper if you are interested. Okay, right. So what is special about this algorithm in the sense it the way in which it generates new population and the way in which it performs selection for mating. For mating pool, it has to select the individuals, right? So this generation and selection were done in an innovative way. Okay. So regarding the generation and selection of the Pareto optimal set, ordering and scaling techniques were used. So this algorithm, it uses a technique called as ordering and scaling. So what is ordering, what is scaling, how it does that we'll be discussing, right? Okay. So basically, the innovative thing about this algorithm is how it selects the individuals for the mating pool and how it generates the new population. For that, it basically does something called as ordering and scaling. So for ordering, it uses a technique called dominance-based ranking, and for scaling, it uses a technique called linearized fitness assignment, and fitness averaging. So dominance based ranking means for every solution it gives a rank. For every solution it gives a rank, and then the solutions will be ordered based on the rank. After that, it does something called as linearized fitness assignment and fitness averaging. So that is what is called as scaling. Okay, so these two things are done. So that is why it becomes a unique algorithm. Okay. So what you have to understand in the sense, so what is difference with respect to the normal what you call genetic algorithm and MOGA, in the sense it does something called as ordering and scaling for selecting and for generating the population. Okay, so what is ordering, what is scaling, all those things we'll discuss. So this is the flow diagram corresponding to MOGA. So it is very similar to the normal genetic algorithm flow diagram with a little modification, including those ordering and what you call including ordering and linearization or scaling. So it starts with the initial population and it evaluates the fitness score of the individuals, and then it assigns rank. Rank is assigned to the individual based on their Pareto dominance. Okay, how this rank is done, that we'll discuss with an example. So for the initial population, it evaluates the fitness by using the objective function, and then every solution will be ranked. For ranking, it uses something called as Pareto dominance, and then it performs something called as scaling, which is assign linear scaled fitness. Okay, then based on this ranking, this fitness will be updated. Originally, fitness is calculated based on the objective function. Then based on the objective function, ranking is done. Then based on this ranking, the fitness is updated by using linear scaling. Okay, right? And so as a result, new fitness score will be generated, right? So basically at top level, what it does in the sense, see here, say for example 100 individuals are there initially. Then for all the 100 individuals, here we identify the fitness value. Individual 1, I will call it as I1. What is his fitness score? Okay, say his fitness score is S1. Individual I2, what is his fitness score? S2. So on and so forth. Individual 100, what is his fitness score? S100. Like that, this step it identifies the fitness. Then the next step, what we do in the sense, we do ranking. Now this ranking how it does in the sense, it is a Pareto dominance ranking. So what is a Pareto? What is Pareto optimal set? Pareto optimal set is the set of solutions. Pareto optimal set is a set of solutions which are non-dominating. That is, out of this, if for example, if there is a set S1, okay, say S1 contains some elements. So if I say that S1 is Pareto optimal, then it means that whatever in S1, they are not dominating each other. They are of equal importance. Okay, so it means if I say that this set S1 is a Pareto optimal set, then it means that A1 is not dominating A2, A2 is not dominating A3, so on and so forth. Any one individual of this set is not dominating any other individual. So that is the meaning of a Pareto optimal set. Okay, because how we define Pareto optimality, the solution cannot be further improved without degrading some other objective function. So whatever the solutions available in the Pareto optimal set, all are treated as equal. That is, they are not dominating each other, right? Now this rank based assigning rank based on Pareto dominance means what it does in the sense, even though there are 100 individuals are there, these 100 individuals may fall under different Pareto optimal set. Okay, say for example 10 individuals out of this 100, maybe some 10 individuals may follow under one Pareto optimal set. So we can call it as Pareto optimal set 1. Another 20 individuals may fall in some other Pareto optimal set. Okay, another 15 individuals may be in some other Pareto optimal set 3. So like that, there may be some group of individuals which may be in one Pareto set. That is, in that group you cannot differentiate who is better than other. That in that group all of them are not dominating each other. Okay, so like that there may be several groups out of this 100. Okay, so the point is what it does in the sense, for all the individuals in the same Pareto optimal set, it will give the same rank. For example, I'm telling, if all these guys are ranked as 1, if all these individuals were ranked as 1, then all these individuals may be ranked as 2. Then all these individuals may be ranked as 3. Okay, so that is how it does the ranking. That is, from the uh, individuals, it will identify different combinations of Pareto optimal set, and for one particular entire Pareto optimal set it will give only one rank. Okay, so like that the ranks will be assigned. So now you are saying all these 10 are equal, so that they are having one rank. Similarly, we are saying all these 20 are equal, so that they are having some other rank. Like that we assign the rank. Okay, then we perform some linear scaling based on this ranking, right? And then we assign the updated fitness value for these individuals. Now for all the individuals in this rank 1 category, you will give one common fitness score. Okay, you say that everybody here is 93 fitness. Here everybody is fitness is 88. Okay, because they are in one rank category. So that is what is called as assign share fitness. Okay, so these are the 3 steps it does. Then you check whatever the best solution, you take it and see whether it is converged or not. If it is converged, then return that as the Pareto optimal set. Okay, not one solution, it's a group of solution. If it is not converged, then again we repeat the process. We select a group of individuals by using some probabilistic approach. So that is called as stochastical approach, right? And again we repeat all these process. So this is how at the top level how this technique works. Okay, move on. So well, so there are two important things here we have to do. One is ranking, the other one is linear scaling. So first let us try to understand what is meant by rank of a solution. Okay, what is the rank of a solution? So this is a very easy definition to understand. For an individual x, for an individual xi, if an individual xi is dominated by pi individuals in the current generation, then the rank of xi will be equal to 1 plus pi. Okay, it's I think it's very simple definition. If an individual xi is dominated by pi individuals, so there is an individual xi. Individual means there is a solution xi, and we are saying that this solution is dominated by another pi solutions. It means that pi solutions, there are already pi solutions which is better than xi. Then what will be the rank of xi? Obviously rank of xi will be 1 plus pi, because exactly you know that this many individuals are better than xi, so its rank will be 1 plus pi. Okay, the rank of a certain individual corresponds to the number of chromosomes in the current population by which it is dominated. So chromosome means individual here. Okay, instead of chromosome you can call it as individual or a solution. Chromosome, individual, solution, all these things refers to the same thing. Okay, so the rank of a certain individual, the rank of a particular individual corresponds to the number of individuals in the current population by which it is dominated. That is, if you want to identify the rank of individual k, then you should know how many individuals were dominating k. So if I know that there are, say, some x individuals were dominating k, then I can identify the rank of k. Are you getting? If x individuals were dominating k, then what will be the rank of k? Any answer? If x individuals are dominating k, then what will be the rank of k? Say 1 plus This 1 plus what? X individuals are dominating K. So what is 1 plus? 1 plus X. Yeah, good. 1 plus X. Because already you know that X individuals were dominating K. So the rank of K will be 1 plus X. If nobody is dominating K, then what will be the rank of K? 1. X is 0. Are you getting? So this is the best rank possible. Okay. So this is the lowest rank is the best rank possible, and which is 1. So if some individual is having rank 1, then it means that there is no solution which is dominating this solution. Okay. If 5 individuals were dominating K, then what is rank of K? 6. Okay. So that is how the rank is calculated. If an individual xi is dominated by pi individuals, then the rank of xi is nothing but 1 plus pi. Fine. So here is an example of so say this is an objective function which is based on two functions f1 and f2. Say we want to minimize f1 and also we want to minimize f2. So our objective is to minimize both f1 and f2. Okay. Now say I want to find the rank of this individual, this particular individual's rank. So what will be his rank? What will be the rank of, pardon? 1 plus uh, no, which xi you are talking about? There are two xi here. This is not small xi is just this individual. Okay, that is small xi. This is capital xi. It represents this entire region. Xi is this individual. We want to identify this rank only. Now, what is the definition of rank? 1 plus what is pi? No, no, don't. Pi expand the tell the meaning of pi. Put it in words. Rank of an individual is equal to what? 1 plus the rank of an individual corresponds to the individuals. Which individuals? Rank of an individual. See this definition. The rank of a certain individual corresponds to the number of individuals in the current population by which it is dominated. Dominated, right? So rank of xi is what? 1 plus put it in words. I'm not asking any answer. 1 plus the individuals which are dominated by xi, right? 1 plus the individuals who are dominating xi, right? Here, which region is dominating xi? This is minimization problem. Both we want to minimize. So which region is dominating xi? This region is dominating xi. Is this region is dominating xi? Is the unshaded region is dominating xi? No, this shaded region is dominating xi. So in this shaded region, how many individuals are there that we should count? Is it clear? In the shaded region, how many individuals are there that you should count? All these individuals are dominating xi. Okay. So that is what this thing represents. So rank of xi is nothing but 1 plus this symbol xi, which means the number of individuals in this shaded region. This is capital Xi. Okay. So where this xi represents the number of solutions in the shaded region. Why? Because these are the individuals who are dominating xi. Okay. So here is a more precise example. So you can see here. So this is maximization. F1 we want to maximize, F2 also we want to maximize. We want to maximize both F1 and F2. Say we want to identify the rank of this individual. Okay. Now how will you identify his rank? Yeah, the PI individuals who are dominating Xi. Okay. So uh, so which individual they are? Which part of the curve it is? Right side, and so is this region is dominating Xi? This region, which region is dominating? This region is dominating Xi. Okay. So here, how many individuals are there? You have to count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9, 10, 11. Right. So there are 11 individuals are there who are dominating Xi. So this line also we are taking. So 11 plus 1. So the rank of Xi is what? 12. Okay, like this the rank is calculated. So like this we have to calculate rank for every individual. See for example this diagram. Say this is also we want to calculate the we are calculate the rank for every individual. Say this is max of F1 and max of F2. I mean F1 is also we are maximizing, F2 also we are maximizing. Okay, so let us consider these points, right? So so this is the what you call, this is the Pareto optimal. So this region, if you see, this is Pareto optimal front here. Okay, because here nobody is dominating anybody. Nobody is dominating anybody, right? Or what do you call? Sorry. See, this is not a solution at all here. Okay, this is just for understanding. This is not a part of the solution. This is not a part of the solution. These are the solutions. These small circles are no. These small circles are the solutions. Okay. Now you tell how they are ranked. See, this is rank. These two individuals are ranked as 1. Why? Both of them are here ranked as 1. Why? Hmm? Okay. No, I'm sorry. So sorry, this is also a solution. You consider this also as a solution. 1, 2, 3. This is also a solution. Say this is the Pareto optimal front. This is the Pareto optimal front because maximizing this and we are maximizing this. Okay. But say for these individuals, is there anybody dominating these individuals? Is there anybody dominating this who are lying in this Pareto optimal front? No. Okay. So let us assume that here these individuals are ranked as 0. So normally ranking starts with 1. So as per the definition it should be 1. Okay. But for this problem, so let us assume these are individuals ranked as 0. Their rank is 0. Okay. Right. Now you see these two solutions. Okay. You see this. You take this solution alone and you see how many individuals are there who is dominating this individual. How many individuals are there who is dominating this individual? Pardon? Two. Who are the two? Which two? No, no, 8, this is rank. This is not any number. This is rank. Okay. This two, these two individuals rank is 1. That is what it means. This individual's rank is 2. This is how it is being calculated. That's what we are trying to understand. You just see the diagram and say who is dominating this particular individual. See, we want to maximize both F1 and F2. Okay. So, which point in the graph is better than this? So better than means somebody who is right to this and also to his top than this. How many such individuals are there? Okay, see here, if you see, who will you give the who is the one who is what you call whom will you say that who is, say for example, this individual, if you take only this individual is dominating this individual, nobody else is dominating, only he is dominating. He this Can you say that this individual is dominating this individual? No. So there is only one person who is dominating this individual. Okay. So already we said that this his rank is 0, so it is 0 plus 1, so 1. Okay. Now if you see this particular individual, how many individuals are dominating this individual? Which is that one? Only not adjacent. This adjacent one, it is to the top. This one only he is dominating. Is he is dominating this one? Is this no? Why? Because he is towards what? This individual and this individual. Why we are saying that this individual is not dominating this individual? When you can say that someone is dominating other? When in this case, when I can say that Y is dominating X? When I can say Y is dominating X? Hmm. So okay, let us, okay, the value, okay, that is fine. But here what we want to do, F1 also to the maximize and F2 is also maximize. Okay, middle one, yeah, that is what I am expecting. So when you say that Y is dominating X, if Y is towards the right of X and also Y is towards the top of X, are you getting? Then you can say that Y is dominating X. Is it clear? So this individual, is this individual is dominating this individual? This individual, is he is dominating this individual or not? He is not dominating him because he is to the top, but is he to the right also? No, so he is not dominating. Whereas we say that this individual is dominating this individual because he is to the top and also he is towards the right. Are you getting? So anyway, this individual is dominated by only one individual and his rank is 0. So 0 plus 1 is 1. Similarly, next if you see this individual, okay, if you see this individual, he is dominated by how many individuals? Why no individuals? Is there nobody to his right and to his top? Yeah. How many are towards his right and towards his top? Why no one is towards his right? Both you see. How many are towards his top and right? Both conditions you tell me. How many are towards right and top? Is this guy is towards right and top? Is this is towards right and top? Is this is towards right and top? No, this is towards top but not. Yeah. Is this is towards right and top? No. So how many towards right and top? So this rank is 2. Are you getting? Actually it should be 2 plus 1 3, but here they are representing 2. Is the point is clear? So similarly the previous case also that same thing only. If you see this individual, how many towards his right and top? Only 1. Okay, so its rank is 1. How many towards his right and top? Only 1, right? So that is how it is. So as per the definition, it should be, you should add plus 1, but here it is represented in different way. Like different books follow different format, no? Okay, now you see this individual, how many towards his right and top? Only 1. Who is that? Only this. Yeah. This point is towards right, but it is not towards the top. Okay. Similarly, with reference to this individual, you see how many towards the right and top? Only 1. So can you say he is towards, so it means this individual is dominated by only this individual. This individual is not dominated by him. Why? Because he is towards top, but he is not towards the right. Okay. Similarly, this individual, how many are towards his right and top? Yeah. So how many are dominating this individual? Only 1. So the rank is 1, right? Okay. Actually, it should be 2, but here it is 1, right? You see this individual, how many it's towards his right and top? Everything you see, entire set. To the right and top. What about this? Is towards right and top or not? Yes, 1. So this individual is towards right and top or not? This is towards right and top or not? So this is also towards right and top, right? This is also towards right and top. This is also towards right and top. 1, 2, 3, 4, 5. Okay. You see this 2 points. This is also towards, okay, right and top. So this is 8. Is it clear? So this is how this rank is calculated. Okay. Actually, another 1 should be added. So so if you follow as per definition, then what will be their ranks? No, as per. So as per definition, if you follow, this will become what? 2. This will become 3. This will become, okay, right? So this will be 1. All these things, their rank will be 1. Okay, because is there anybody who is towards right and top of this individual? Is there anybody towards right and top of this individual? Is there anybody towards right and top of this individual? So nobody is dominating them. Okay, so their rank is 1. So somebody who is not dominated by anybody, their rank will be 1. Okay, somebody who is dominated by one person, one individual, their rank will be 2. So first we assign rank like this for every individual. This algorithm, what it says in the sense, you have to identify the rank, and this rank is a Pareto optimal based rank. Why it is a Pareto optimal based rank? Because you can see here a group of individuals will be given same rank. These 2 individuals are given 1 rank. Like that, multiple individuals will share the same rank. Okay, and some rank, it is not that the rank should be continuous. See, for example, here we have 1 2, there is no 3 4 5, right? Is there, in this case, is there 3 4 5 rank is there? Directly the rank went on to 8. Or in our case, properly if you rank also, it will become 2 1 2 3 and or 9. Okay, so like that also it happens. So it is not that all rank should be followed in a sequential way. Okay. Okay. So dominance count. So how do we calculate the dominance count, in the sense how many individuals does an individual dominates, right? So so that is what is called as a dominance count. All dominated individuals, all non-dominated individuals. So the individuals who are not dominated by anybody, they will be assigned with rank 1. Okay. All dominated individuals are penalized according to the population density of the region of the trade-off surface. Okay. So that means what? If some individual is not dominated by anybody, then their rank will be 1. If some individual is not dominated by anybody, then their rank will be 1. If somebody is dominated by somebody else, then they will be penalized. Here penalizing means they will be given more rank. Okay, increasing the rank is called as penalizing. Okay, so the higher the rank, higher he is penalized. So the algorithm, what it says in the sense, first sort the population in ascending order based on the rank. That is, first we assign the rank, like how whatever we did so far. In that process, by referring the objective function, we assign the rank. Then sort it in ascending order based on the rank. Then assign fitness to individuals. This is new fitness. This is not the original fitness. Then based on the rank, we are going to assign new fitness value to the individuals by interpolating the best rank to the worst rank. Okay, we are going to make some interpolation between the best rank and the worst rank. So by that process, we are going to assign the fitness value, right? Where the best rank is 1 and the worst rank will be less than or equal to n, where n is the population size. Okay. So we'll be using some linear function. So based on this linear function, this interpolation will be done. We'll be interpolating the best rank with the worst rank, and the new fitness score will be evaluated. And then what we do, average the fitness of the individual with the same rank, so that all of them are sampled at same rate. Okay, that is, for all individuals who are in the same rank, their fitness will take the average of their fitness. For all of the individuals in the same rank, we will take the average of their fitness value. After interpolating after assigning the new fitness value, then we take the average of the fitness value of all individuals in the same rank. So this is how the algorithm works. So for example, say so now we are going to discuss about linearization. So there are 2 steps in the algorithm. One is ranking. So first we discussed about ranking. So these are the examples where we discussed ranking. After assigning ranking, what you have to do, you have to interpolate the best rank with the worst rank, and you have to identify the fitness by using some linear function. So how this is being done? This is called as scaling. So that is what is being explained here. Say this is the what you call a particular objective function is represented like this. Okay. So now if you see, these individuals are not dominated. Say the objective function is to is to maximize. It is to maximize f1 and f2. Now you can say that these individuals are not getting dominated by anybody. So the individuals who is lying in this Pareto optimal front, they will have the rank 1. So their rank will be 1. Okay. And similarly, if you see the individuals lying in this Pareto optimal front, they all will have the same rank. They all will have the same rank. Okay. So like that, there will be multiple individuals with same rank. Now how linearization is done in the sense, fi dash is equal to sigma j equal to 1 to k fij by fij bar. Here actually there is a, so it is fij by fij bar. Okay. So what is fij? Fij denotes the jth objective function of a solution in the ith rank. Okay. So fij denotes the jth objective function of a solution in the ith rank. So this is, if this is first rank, say we call this all the individuals who is here, their rank will be 1. Okay. Say all the individuals who is in this Pareto optimal front, their rank is 2. Okay. So it means that the fij denotes the jth objective function of a solution in the ith rank. So in the ith rank category, what is the jth objective function? We have many objective functions. We are talking about multi-objective optimization problem. So f1, f2, say we have up to fk objective function. Okay. So here fji represents the jth objective function of a solution in the ith rank, and fji bar denotes the average value of jth objective of all the solutions in the ith rank. Okay, that is average solutions of average value of jth objective function. So all objective function you have to apply. So if you take only one objective function, say f1 instead of fj, let us call it as f1. So then it will be f1 I bar denotes the average value of first objective function for all the solution in ith rank. If it is first rank, then for all the solution in the first rank, that is, it is the average of all these points. Okay, so it's the average of all these points, right? So that is how we perform linearization. So that means that basically for all these individuals you are giving one fitness score. Okay, for all these individuals we are going to give one fitness score. Like that we are going to assign fitness for every individuals who is sharing the common rank. Okay, so we are not going to discuss any example on this, but just to understand that I understood this is not easy to understand, but probably this will make the point clear. So finally what happens, these are the different individuals. So multiple individuals will have rank 1. Similarly, another set of individuals will have rank 2. Another set of individuals will have rank 3 up to rank q. All the individuals in rank 1 will be mapped to one particular fitness value, that is f1. All the individuals in rank 2 will be mapped to some other fitness score f2. And all the individuals in rank q will be mapped to some other fitness score fq. Okay, right? So then we see whether the convergence is met or not. Otherwise, these individuals will be identified as the next generation of population. Okay. So this is how this algorithm works. So first it does ranking, and then it interpolates the best rank with the worst rank based on some linear function, and it performs scaling. As a result of scaling, what we get in the sense, all the individuals corresponding to a particular rank will be mapped to a particular fitness score. Okay, and then we see whether the solution is converged or not. If it is not converged, again repeat the process, right? So the remarks on MOGA is, the fitness assignment in MOGA attempts to keep the global population fitness constant while maintaining the appropriate selection pressure. Okay, so that is, in each round we are ranking, and based on the rank we perform interpolation. That is, interpolation means we perform some mapping between the best rank and the worst rank. Okay, rank 1 and rank n. Based on this interpolation only, we are assigning the new fitness score, such that all the individuals lying in the same rank, they will get the same fitness score. Okay, while doing that, the algorithm ensures that the global population fitness will be constant. The global population fitness will be constant while maintaining appropriate selection pressure. Okay, that is, it increases selection pressure at every round. MOGA follows blocked fitness assignment, which is likely to produce a large selection pressure that might lead to premature convergence. This is considered as one of the drawback, because what happens now, initially before applying MOGA, say if you have 100 individuals, 1 to 100, all the 100 individuals will have different fitness score. Fitness 1, fitness score 1, 2, like that everybody will have their own fitness score. But once you apply one round of MOGA, what happens? It will identify the group of individuals in the same rank. So all the individuals in the same group will be given same rank. Okay, so at the end of first round, if there are 10 groups, then there will be only 10 ranks. That is, all the individuals in each group is treated as only one rank. So now what happens? Previously in the first round you had 100 ranks. In the next round the rank becomes only 10, which means the selection pressure is increasing now. Now out of, previously you have 100, from 100 selecting 2 for mating is easy. You have much options are there. Now only 10 is there. Okay, so there is no variety, or there is no so there is a doubt that the algorithm may converge prematurely. Okay, but actually in reality MOGA found to be better. It is able to produce near optimal solutions in majority of MOOPs problem, right? Even though it is expected that it will increase the selection pressure, but actually in reality it is performing better, right? So this is what about MOGA. So could someone summarize how MOGA works? Yes. Hmm. 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 Yeah, linear scaling. Hmm. 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 So what is ranking? Hmm. Hmm. So that is rank, like, so using that formula we'll identify rank for every individual such that xi is equal to 1 plus pi, where pi represents the individuals who are dominating xi, right? After ranking, what we do? After ranking, what the algorithm says? This is the algorithm. Yeah, sort the individual based on their ranking. Then what should we do? Then we should calculate new fitness score. For the individuals. By how we are going to do that? By interpolating the best rank with the using some linear function, right? So as a result of that, what happens? As a result of this performing this operation, what will happen? The individuals who are falling in the same rank will have the same fitness value. Okay? The average of the fitness of the individual with the we average the fitness of the individual with the same rank, so that all of them are sampled at the same rate. So after performing all these steps, what happens in the sense? All the individuals in rank 1 will have the fitness score what? F1. Okay, all the individuals in rank 2 will have the fitness score F2, right? So like that it happens, right? So because of that, it is observed that MOGA increases the selection pressure at every round. So when the selection pressure will increase? When the population is less or population is more? Yeah, when population is less, selection pressure is in. selection pressure will be high. Here we are not decreasing the population, but we are saying that all these individuals are same fitness score. So that is also like what? We are putting everybody in the same category in each round. Are you getting? So it means that selecting anybody in this group is equally same. It is not that. So it means that for a mating for a mating pool, if you want to select two individuals, if you cannot select two individuals from the same rank because they are similar, right? So if one individual is from this rank, another individual should be from this rank. So that is why we say that it increases the selection pressure, because at every round we are forming groups, and all these groups we are putting under same rank and same fitness score. Okay, but in spite of that, actually MOGA is producing better result. It is able to produce results which are close to the optimal solutions. Right. So the next, so MOGA is the one of the Pareto based approach for solving MOOPS problem. The next approach that we are going to discuss is NPGA. NPGA stands for Naicht Pareto genetic algorithm. So this is again this is available in this journal. In this journal, it is a technical report of University of Illinois. It's not a journal; it's a technical report from this university. So I think it is available online. If you want, you can check out. It is in this paper by J. Horn and Nafpolitis. Okay, it is introduced in the year 1993. It is multi-objective optimization using Naicht Pareto genetic algorithm. So this algorithm actually it uses a tournament-based selection scheme. So previously we have discussed several selection algorithms. So one of the selection algorithm is called as tournament-based selection algorithm. So this NPGA basically it uses tournament-based selection algorithm. And it also works on Pareto optimal principle. So what it does in the sense, it first selects two individuals randomly. Individuals means solution, or you can call it as chromosome. So it selects two individuals randomly. Then to find the winner solution, what it does in the sense, it creates a comparison set that contains the number of other individuals in the population. Okay. Then it calculates the dominance. Then the dominance of both the candidates, here it selects two candidates, no, their dominance will be compared with the comparison set, right? So if one candidate dominates everybody in the comparison set, and if another candidate is not dominating everybody in the comparison set, then that candidate will be chosen as the winner, right? Otherwise, say for example, if both the candidates are dominating everybody in the comparison set, then what we do in the sense, then we follow a technique called Naicht sharing to decide the winner. Okay. So I'll explain this with the, say for example, the algorithm basically what it says in the sense, it says select two individuals. Let us assume these two individuals are C1 and C2. Then what it says in the sense, you form a comparison set by identifying some n individuals. You identify n individuals, and with that you create a comparison set. So the comparison set contains some individuals. Say it contains individual I1, I2 up to IN. Now the algorithm what it says in this sense, you check whether C1 is dominating everybody in I1 or not. I mean in this comparison set or not. We call this as CS, comparison set. You check whether C1 is dominating everybody in this set or not. If C1 is dominating everybody in this set, then that is fine. Then take C1. And then check is C2 is also dominating everybody in this set or not. Okay. For example, if C1 is dominating everybody in this set and C2 is not dominating everybody in this set, C2 is dominating somebody and not dominating somebody else, like that, but C1 is dominating everybody in this set, then we say that C1 is winner. Okay. The other way around, if C2 is dominating everybody in this set and C1 is not dominating everybody, then we say that C2 is winner. Okay. If both C1 and C2 are dominating everybody in this set, then in that case we have to follow a technique to identify who is the winner, and that technique is called as Naichut sharing. So then the Naichut sharing technique will identify the winner. Okay, so could someone summarize what I said so far, how MPGA technique works? Yes. Hmm. Hmm. No, no, who is dominating? Who say C1 and C2 are the two individuals. So C1 comparison set should not dominate. Who is dominate? Who should combinate? Who should dominate the comparison set? If C1 dominates everybody in the comparison set, and C2 does not dominates everybody in the comparison set, then who will be the winner? No, no. The question is clear. Say C1 is dominating everybody in the comparison set. C1 will be the winner, right? If C2 dominates everybody in the comparison set, then who will be the winner? I mean C2 dominates and C1 does not dominates, then who will be the winner? C2 will. If both C1 and C2 dominates everybody, then who will be the winner? Yeah, then you have to follow this technique, niche sharing, right? Okay. So basically what it says in the sense, say for example, in simple terms, assume that uh, there is a competition between say many countries. Say there is a cricket competition or any competition, say India, uh, say Australia is there, say Pakistan, England, South Africa, Kenya. Okay. So now you want to find who is best, India versus Australia. So this is the one we are picking up. So C1 is India, C2 is Australia. Okay, now out of these two you have to say who is the winner. Okay, so this algorithm, what it says in the sense, for that you have to first create a what you call comparison set. So in the comparison set it will identify some individuals. Say it Pakistan is here, England is here. It need not bring everybody. Say South Africa, say Kenya is not in the comparison set. Then it conducts match between India, Pakistan, India, England, India, South Africa. So India should compete with everybody in this comparison set. Say by competing with everybody, say India is the winner. Then Australia should compete everybody in this comparison set. Okay, so after competing, say Australia got lost to South Africa, right? So then we say that C1 is the winner, that is India is the winner. The other way around, if Australia won over Pakistan, England and South Africa, but India when it is competing, it has lost with South Africa, then we say that C2 is the winner, right? If C1 also wins everybody in this comparison set, and C2 also wins everybody in this comparison set, then you have to follow what technique? Yeah, niche sharing, right? So basically that is what the algorithm says. So it says that first you just randomly pick up two individuals, C1 and C2, then form a comparison set. Then you see whether C1 dominates everybody in the comparison set. If C2 does not dominates everybody in the comparison set, then C1 is the winner. If C2 dominates everybody in the comparison set and C1 does not dominates, then C2 is the winner. If both of them dominates everybody in the comparison set, then what do you do? Then you follow the niche sharing technique. Okay. Here the algorithm is explained. Say let n be the size of the population. N is the size of the population. K is the number of objective function. K is the number of objective function. I is equal to 1, that is first iteration. Randomly select two candidates, C1 and C2. and randomly create a comparison set of individuals from the current population. So what should be the size of the comparison set that the programmer can decide? It should be n star, where n star is equal to p percentage of n. N is the total size. Okay, so you may take some percentage depending on the population size. It may be 10% or 20% or 30%. So it is p percentage of n. N will be that n star will be decided by the programmer exactly how many percentage it should be. Check the dominance of C1 and C2 against each individual in CS. Check the dominance of C1 and C2 against each individual in CS, where CS is the comparison set. If C1 is dominated by CS, if C1 is dominated by CS, not by C2, C1 is dominated by CS, which means what? Which means who is dominating who? C1 is dominating CS or CS is dominating C1? What it says? If C1 is dominated by CS means who is dominating who? What? Oh, no, be simple. Who is dominating who? Is CS is dominating C1 or C1 is dominating CS? Yeah, CS is dominating C1. In that case, we say that who is the winner? C2 is. In that case, we say C2 as the winner. Okay. Else, if C2 is dominated by CS but not by C1, then we say that C1 as the winner. Okay. Otherwise, C1 nor C2, neither C1 nor C2 dominated by CS. Okay. That is, both of them are dominating CS. In that case, we do sharing. That is, we should do night sharing and choose the winner. Okay. So like that, this will be done again after doing this. Again after doing this, we check whether the problem is converged or not. If the problem is not converged, then again we go for the next iteration. Okay. So that is what I is equal to m dash. That is, if the problem is not converged, go to the next step. Again repeat this process. So sharing will be done when there is no preference in the candidates. So this maintains the generic diversity, allows to develop a reasonable representation of Pareto optimal front. The basic idea behind sharing is that more individuals are located in the neighborhood of a certain individual, the more its fitness value is degraded. Okay, the more its fitness, the sharing procedure for any. So basically, what it says in the sense, the basic idea behind sharing is that more individuals are located in the neighborhood of a certain individual, the more its fitness value is degraded. So say for example C1 and C2. So say that C1 is also dominating CS, C2 is also dominating CS. In that case, how will we identify who is the winner? So we are going to do sharing. So the whole idea of sharing is we are going to identify how many neighbors are there near C1 and how many neighbors are there near C2. Okay, we are going to identify how many neighbors are there near C1, and also we are going to identify like how many neighbors are there near C2. Okay, so based on that only we are going to decide like who will be the winner, right? So the one who has more neighbors, we are going to choose that person as the winner. So this is how the sharing algorithm is proposed. Let j equal to I, j equal to 1, x is equal to C1. So sharing algorithm should be followed for both C1 and C2. So this algorithm is written in terms of C1. Similarly, it should be repeated for C2 also. So initially we are considering for C1, compute the normalized Euclidean measure with the individual xj in the current population as follows. So we have to calculate the Euclidean distance for xj, where initially j is 1, so that is x1. x1 is the one solution. Let us say it is the first solution. So I mean, the problem, the entire solution set may have, we may have many solutions. We may have 100 solutions. Take the first solution. Okay. So dxj is equal to sigma j equal to 1 to k, where k is the number of objective function. F ix minus fij divided by fiu minus fil, where fij denotes the ith objective function for the jth individual. Fij represents the ith objective function for the jth individual, and fiu and fil denote the upper bound and the lower bound values of the ith objective function. Okay. So if there are k objective function, say if there are 5 objective function, then k is equal to 5. Then we need the upper bound and lower bound for the first objective function, upper bound and lower bound for the second objective function, so on and so forth. Okay. When I is equal to 1, we are talking about the upper bound and lower bound of the first objective function. When I is equal to 2, it is upper bound and lower bound for the second objective function. Okay. So ij, this is ij, it denotes the ith objective function for the jth individual. Individual represents number of solution. So if there are 100 solutions, then with respect to the first objective function, what is the first solution value? Okay, for which value of x it is giving this solution for the first objective function. So that is fij. Okay, right. Fix is which solution here we are taking. Initially we are taking x as c1. Okay, that is the solution, the first solution we are taking. So fix is subtracted from fij. Okay, so fix is, I is, say if I is 1, then it is with respect to the first objective function, this solution is subtracted from the first objective function with respect to first objective function for all solutions. Okay, so and it is divided by the upper bound minus lower bound. Okay, so like that we calculate dxj. Once that is done, then we calculate something called as sh of dxj. Okay, to calculate this sh of dxj, you have to identify some value for this Naiche radius. This is called as Naiche radius, sigma share. Again, this is a programmer's choice. Programmer should choose this value. If this, whatever the value the programmer is choosing, this value, this Naiche radius, if it is less than dxj, dxj is calculated in the previous round. If it is less than dxj, then sh of dxj is calculated using this formula, 1 minus dxj by the Naiche share the whole square. Otherwise, if suppose whatever the value of this is selected, if it is greater than this, then this will be 0, right? Then we increment j by 1, and then we check whether j is less than 1, j is less than n, where n is the number of individuals. If j is less than n, then go to step 2. What is step 2? Step 2 is this, that is, so far j is 1 means that means we did this for the we did this only for the first individual. Like that, do for the second individual. Okay, do for the third individual. So like that, for all individuals it should be done. For every individual we do that. Okay, so for every individual we calculate this xh of dxj. So with respect to the here x represents c1, that is with respect to c1, how the other individuals are close, especially in this radius dxj, in this radius, in this Naiche radius. Okay, so we will get many xh of dxj, right? So all those, so after n iteration is done, then what we do, then we calculate n1. n1 is nothing but sum of all this sh of dxj. Okay, sum of all this sh, so that is n1. So this is for c1. Similarly, you have to do for c2. The same thing we should repeat for c2. Okay, so then after repeating the entire thing for c2, then you have to check whether n1 is less than n2. If n1 is less than n2, then we say that C2 is the winner. Otherwise, we say that C1 is the winner. Okay. So whoever is greater than, they are the winner. So in this case, n2 is the greater, so we say that C2 is the winner. Right. So this is what how the algorithm works. Right. See, at the top level, what you should understand in the sense, you are not able to understand this entire thing exactly. Basically, it identifies how many individuals are close to C1 and how many individuals are close to C2. Okay, and based on that only it decides like who is the winner, like that. So, for example, here why we are calculating this this radius, we are doing something, right? This radius will identify exactly like uh, how many are near to the particular individual, right? That is, if it is C1, how many are near to C1. So this represents the, say for example, C1 is located somewhere here. Okay, and if you select some radius, then it is something like it draws a circle like this function, that is what it does, and then it checks who are in this area, how many are in this area. So that is what we are counting through this. Okay, so you can see it will be it just checks whether an individual is in this area or not. Okay, if it is not in this area, it will be 0. If it is, what is the probability of a individual lying in this area, that is what it calculates, 1 minus this, right? So finally we add all those probabilities. So the probability of the individuals, how many individuals lying close to that, so that is what is called as n1, right? Similarly, the probability of number of individuals who will be close to C2, so that is called as n2, and then we check who is less than who, and if someone is less than the other person, then we say that the other one is the winner. Okay, and if you see here, this function, what it does in the sense, see here, let us be very clear. See, we can try to what you call split up this function for better understanding. Say in the first round, j is 1, x is c1. Okay, so instead of writing like this, what we can write as I represents the for each round, this equation will go from 1 to k. Okay, so I represents the number of objective function, so that is anyway that has to be repeated. So fi x is what, c1, so fi c1 minus fi in the first round, in this round j is 1, fi1. Okay, I represents the objective function divided by fi u minus fi l. Okay, sigma I is equal to 1 to k, where I is the objective function. So what it says, with respect to, say again, this goes for how many rounds, k rounds, where k is the objective function. Okay, so if I is initially 1, then it says that with respect to first objective function, what is the value of c1, what is the value for which value, c1 is one of the solution, so you have any solution. Okay, so c1 is one of the solution. With respect to first objective function, for what value of x or what value of x, it gives this as the result, that is what here we are checking. Okay, fi c, right? Similarly, fi1 in the sense, with respect to the first objective function, for what value this one represents first individual is maybe this individual. Okay, so with respect to first objective function, for what value you are getting this as the output. Okay, right? So basically it means what, you are subtracting this and this in the first round, right? In the next round, this is again, if you see, with respect to the second objective function, what is this? And with respect to the second objective uh, function, again, this is what is 1. With respect to the second objective function, what is this? Again, you are subtracting. Like that we are doing. So we are basically mapping the gap between this and this. Okay, in the first round, we are trying to identify the gap between C, the result C1 and the first individual. Similarly, in the second round, we are trying to identify the gap between C and the second individual. Okay, so that is what it does, and it is averaged by the upper limit and the lower limit of that particular objective function. Okay. Once we have found that, then we select this radius thing, sigma share, which is the Naichel radius, and then we check in the previous round whatever we have calculated, that is the sigma is dxj is less than sigma share. If it is less than, then you calculate sh of dxj using this formula. Otherwise, assume sh of dxj as 0. Okay, so repeat this above process for n times. So you will get n sh of dxj, right? So then you add all those things. So when you add all those things, what you get is called as n1. So this is done for C1. Repeat the same process for C2. When you do for C2, you will get N2. Now compare N1 and N2. Whichever is greater than, that is the that is the winner, right? Fine. Let us stop here for today's session. So Saturday we'll have test 1. Okay. So the topic will be up to this, from the beginning to till today's class. Okay, from first lecture, right, to today's lecture, whatever we have discussed, be prepared.